Well, here we go with Lesson 1, Part B. This is the second part of Lesson 1, Section 6.1, and we're still dealing with angles. To identify the angle measurements between two whole degrees, like say between 44 degrees and 45 degrees, we have two choices. We can describe them as degree decimals. It's referred to as DD, and this is mostly how students like it because it's just a plain old decimal. We're here 150.1234 degrees. Obviously, it's a little closer to 150 degrees than it is 151 degrees. And the other way we do it, it was degrees, minutes, and seconds. And what we do here is we divide every degree down to 60 minutes, and every minute is divided down to 60 seconds. And so this is an equivalency here. 150 degrees, 7 minutes, 24 seconds is roughly 150.1234 degrees. And so here's our first problem. Find the angle that is complementary to 45.7 degrees. And remember, complementary angles are those angles that add up to 90 degrees or pi over 2 radians. In this case, it'll be 90 degrees. And so 90 degrees minus 45.7 degrees gives us 44.3 degrees. So 45.7 and 44.3 degrees are complementary because they are the two angles that make up a right angle. Find the angle that is supplementary to angle theta, which is equal to 155.41 degrees. Supplementary angles are those angles that add up to 180. So 180 minus 155.41 degrees gets us 24.59 degrees. Not bad. So let's move on and talk about degrees, minutes, and seconds. And I've already given this away a little bit. We divide every degree down into 60 minutes. So you can kind of think about the clock on the wall. Replace the word degree with hour. There's 60 minutes in a degree, just like there's 60 minutes in an hour. And we divide every minute into 60 seconds. And that is exactly like the clock on the wall. So if there are 60 minutes in a degree and there are 60 seconds in a minute, how many seconds are in 1 degree? And that's a pretty good question, and my answer is a lot of them. So 60 times 60 is 3,600. There are 3,600 seconds in a degree. You got to realize how small a minute is. If you took a 1 degree angle, which is really hard to draw a 1 degree angle because it's so small, a minute is 1/60th of that, which is unbelievably small. Well, then a second is 1/60th of a minute, which is really small. And then so you think about it, there are 3,600 seconds in 1 degree. So a 1 degree angle is tough to draw as it is. But could you imagine dividing it into 3,600 equal pieces? That would be tough. So yeah, a second is really small. I just want you to make sure you understand what we're talking about here, the scale of what we're talking about here. So let's go ahead and look at this. Find the angle that is complementary. That's two angles that are up to 90 degrees. To 39 degrees, 34 minutes, and 19 seconds. So we're going to subtract this from 90 degrees, and we're going to have to do some borrowing to cover that 34 minutes and the 19 seconds. So the first thing we do is set it up here. We're going to subtract it from 90 degrees. Notice I've already started to put in those zeros above the 34 and the 19. We're going to borrow a minute, or excuse me, a degree from 90. We're going to turn it into 60 minutes. Then we're going to borrow 1 minute from 60 minutes and turn it into 60 seconds. That's the plan here. It's borrowing. You were used to borrowing with base 10. Well, this is a combination of base 10 and base 60. So you notice I did that. I took a minute. I took 1 degree off of 90 and turned it into 89 degrees. I turned that into 60 minutes, and then right away I borrowed a minute and turned it into 60 seconds. So I only have 59 minutes left over. So that above there, that 90 degrees equals 89 degrees, 59 minutes, 60 seconds, that's something you want to jot down because that's really useful. And hopefully you can expand that to 180 degrees. So now we just do normal base 10 type of subtraction. I got to take 60 minus 19. I got to borrow from the 6, and this is base 10 at this point, like you've been doing since elementary school. So let's wrap this up. With 60 minus 19 is 41. 59 minus 34 is 25, and 89 minus 39 is 50. So 50 degrees, 25 minutes, 41 seconds is complementary to 39 degrees, 34 minutes, and 19 seconds. And how you can check this is actually add them up. Take the two angles and add them. If you add those together, 41 seconds plus 19 seconds would give you 60 seconds. You would add 1. 34 plus 25 gives you 59 minutes. Well, you add the 1 from the 60 seconds, and that gives you a whole degree. 39 degrees plus 50 degrees gives you 89 degrees. Add the 1 degree, and there you go. So you can always check your work to make sure you have the right answer. Well, you probably saw this coming as the next problem. Find the angle that is supplementary to 52 degrees, 13 minutes and 45 seconds. Supplementary angles add up to 180. Same process as before. We're doing the exact same thing. We're just going to use 180 instead of 90. Same borrowing and everything. So I set it up 180 minus 52 degrees, 13 minutes, 45 seconds. You know I've already got the 0 set in. So now I'm ready to borrow a degree from 180, turn it into 60 minutes, borrow a minute, turn it into 60 seconds, and you'll see how we wrap this up. And here's the whole thing. I took 180 degrees and turned it into 159 degrees, 59 minutes, 60 seconds. I subtracted 52 degrees, 13 minutes, 45 seconds from it. And again, this is normal base 10 subtraction now. And I ended up with 127 degrees, 46 minutes, and 15 seconds is supplementary to 52 degrees, 13 minutes, and 45 seconds. And again, you can add those together and make sure they add up to 180, and they do. But it involves a little carrying, but you can always check your work. All right, so now let's do some conversion. And we're going to convert these degrees decimals over to DMS. So I've got 150.1459 degrees, and I want to turn that into degrees, minutes, and seconds. So I'm somewhere between 150 and 151 degrees. I'm closer to 150, but we'll figure that out. Well, the degree part's done. You already know it's 150 degrees. What you want to do is turn the 0.1459 into minutes and seconds. And the number 60 is going to come into play here a couple times. So the degree part is 150 degrees. The minutes and seconds is going to equal to 0.1459 degrees. So what we're going to do is we're going to multiply that by 60 and chuck some stuff off, and then multiply by 60 again, and we'll come up with the answer. So our job here is really to turn 0.1459 into minutes and seconds. The 150 degree part, well, that's done already. So I take off the 150, and I take 0.1459 degrees, and I times it by 60, and I'm really timing it by 60 minutes per degree. And when you do that, 60 minutes per degree, what happens is the degrees cancel, and you end up with just minutes. And I end up with 8.754 minutes. Now, so I'm somewhere between 8 and 9 minutes. Now, if I was told to round to the nearest minute, I would write 9 down. I'm not being told that. I'm being told to round to the nearest second. So we are going to have 8 minutes. And then we'll take care of that remainder when we do the seconds. So we have 8 minutes, and now our job is to turn 0.754 minutes into seconds. And what we'll do is we'll times it by 60 seconds per minute. So 0.754 minutes times 60 seconds per minute, and that's how we get rid of the minutes. We end up with 45.24 seconds. And now we do normal rounding. We will round that down. We're somewhere between 45 and 46 seconds, but we're closer to 45 seconds. And so we're going to go ahead and round that off. And so we end up with 45 seconds. Now what I want to tell you here is I never cleared my calculator in any of this. I entered 0.1459 or 0.1459 in my calculator. I times it by 60. I ended up with 8 point something. I subtracted the 8. I times what was left in my calculator by 60, ended up with 45 point something. Turned out it rounded off to 45. But at no point did I clear my calculator and then re-enter what I had just cleared. Leave everything in your calculator. Just keep subtracting the whole number, times it by 60, and then subtract the whole number, times it by 60, and you round those seconds off. And that's how I do it. So our final answer is 150 degrees, 8 minutes, and 45 seconds is equivalent to, or roughly equivalent to, 150.1459 degrees. So we went from degrees decimals to degrees, minutes, and seconds. So let's do another one. Let's change 12.6789 degrees over to degrees, minutes, and seconds, and I bet you already know the degree part. And we'll just do the whole thing right here. So we know the 12 degree part. That's the easy part. We take the 0.6789 in our calculator. We times it by 60, and that gets us 40.7. So that means we have 40 minutes. I don't round off there. And unless they tell me to round to the nearest minute, then I would make it 41 minutes. But since we're going to round to the nearest second, I don't round yet. Just write down 40. And then I subtract the 40 off on my calculator. I times that by 60 seconds per minute and get 44.04, which we round down to 44. So our final answer here is 12 degrees, 40 minutes, 44 seconds. And again, I leave everything in my calculator. Just subtract the whole number off, times it by 60. Subtract the whole number off, times it by 60. You can knock it out in no time. So now let's go the other direction. Instead of going from degrees decimal to degrees, minutes, and seconds, let's go from degrees, minutes, and seconds over to DD, degrees decimals. So in the previous two examples, we multiplied. So if we're going the opposite direction, you can probably guess we're going to divide. We already know the 45 part. It's 45 point something is our final answer. We got to change 16 minutes into degrees. We got to change 45 seconds into degrees. And those are really small. So we better end up with something less than 1 altogether, because we don't want to go to 46 degrees. So the degree part's taken care of. We know that's going to be 45 degrees. It's the decimal part. It's the 16 minutes 45 seconds that we have to turn into the decimal part. And this is very similar to what we did previously. So we're going to take that 16 and divide it by 60. We're going to take the 45 and divide it by 3600. And we're going to add them up. That's the plan. So 16 minutes divided by 60 minutes per degree is going to give you 0.266666 all the way out there. 45 seconds divided by 3600 seconds per degree. Look how small that is. 0.0125 degrees. So now all I got to do is add those two together, and I'm done with this problem. I just tack that onto the 45. So here what I'm showing you is that the decimal part is equal to the sum of those two decimals. And if I add those up, I get 0.2792 degrees. So I tack that onto the 45 degrees, and I have 45.2792 degrees. And so that's how we go from degrees, minutes, and seconds to degrees decimal. Let's do another one. Let's change 115 degrees, 50 minutes, 12 seconds to degrees decimal. So we know it's going to be 115 point something. We have to turn the 50 minutes, 12 seconds into decimal. So we're going to take the 50 divided by 60, the 12 divided by 3600, add them up. And here's everything. 50 divided by 60 gets you that 0.83333. 12 divided by 3600 gets you 0.00333333. If I add those up, I end up rounding it off to 4 decimals. I don't know, we always round to 4 decimals. And we end up with 0.8367 degrees. Tack that onto the 115, and I get 115.8367 degrees. Well, let's talk about radians instead of degrees. There are two ways that we measure angles. Degrees is what we've been talking about. There's also radians. Kind of like there's two ways we measure temperature. It's the same temperature whether we measure it in Fahrenheit or Celsius. And the same thing happens here with degrees and radians. It's the same angle, whether you measure it in degrees or radians. It's just different units. So let's talk about radian angles and what radian angles are. Well, here's the official definition of a radian. 1 radian is the measure of the central angle of a circle subtended by an arc equal in length to the radius of the circle. So if you had a circle of radius, say 5 centimeters, if you were then to open up a central angle and strike off an arc along the circumference of the circle that is equivalent to 5 centimeters, that angle would be 1 radian. And no matter how big or how small the circle is, that will always be the same value. It is, again, 1 radian is the measure of a central angle that strikes off or subtends an arc out on the circle that's equivalent to 1 radian, to the radius of the circle. Now, since the circumference of a circle is 2 pi r, that's an old formula that you remember from high school. Circumference is 2 pi r. The number of times r units can be laid off is 2 pi. So I can lay the radius off along the surface, around the circumference of a circle. I can lay it out 2 pi times. Again, that circumference is 2 pi r. There are 2 pi r's all the way around. I don't know if that makes sense, but that's why one trip around the circle, which is you would normally think of 360 degrees, is 2 pi radians, because I can lay the radius down 2 pi times, and that's an irrational number, but we have to deal with it anyway. And most students don't care what I just said; they just like this. 360 degrees is equal to 2 pi radians. You know, that's not as useful as that next line, though. If you divide both sides by 2, 180 degrees equals pi radians. I think that's one of the basics of the whole course, is that 180 degrees is pi radians. You'll use that over and over and over again. Notice that when we use radian measures, there's no units indicated. In other words, when we have a degree member, you see the little degree symbol in the upper right-hand corner, like 30 degrees, 40 degrees. With radians, there is nothing to indicate it's a radian. So if you don't see anything, It's in radians. You don't always have the pi with it. Sometimes just 2 radians, 3 radians. Quite often it's 3 pi over 2 radians, that type of stuff. So when you say theta is 5, that means theta is 5 radians. Opposed to theta being 5 degrees means, well, 5 degrees. So again, you see the difference there between having a degree symbol and not having one. If it's all by itself, it just means radians. Now, since 180 degrees equals pi radians, we can use these ratios. Pi radians over 180 degrees or 180 degrees over pi radians. Normally, you don't write radians. You say pi over 180 degrees or 180 degrees over pi. They both equal 1 because they're equivalent. And that's what we're going to use to convert from degrees to radians and radians to degrees. You always multiply by 1 because you don't want to change the value any. But you're going to let the units do all the talking. We're not going to try to memorize anything. So to remember which one to use, think of which unit needs to be canceled and then which unit needs to be left. If I want to have degrees when I'm done, then I want to use the one that has 180 degrees in the numerator. If I want to have radians when I'm done, then I want to use the one that has radians in the numerator, or rather pi. And we'll show some examples here. So when we want to convert between radians and degrees or between degrees and radians, you multiply by pi over 180 degrees to convert from degrees to radians. That's because you're getting rid of degrees and you want to be left with radians. We multiply by 180 degrees over pi to convert between radians to degrees because we want to have degrees when we're done and we want to get rid of the radians. And I'll remind you that we don't use 3.14 per pi, we use the pi key. So let's do an example here. Find the exact radian measure. So I want to convert 30 degrees over to radians. I want to get rid of degrees, and I want to have radians when I'm done. So notice I multiplied by pi over 180 degrees. And the reason I do that is because the degrees cancel out. I let the units do all the talking. I never memorize what to multiply by. So degrees cancel. So notice in that second step I have 30 pi over 180. Degrees are gone. And 30 goes into 180 6 times. So 30 degrees is pi over 6 radians. Whatever you want to get rid of goes on the bottom, and whatever you want to have left goes on top. I wanted to get rid of degrees. I wanted to have radians when I was done. All right, let's convert 60 degrees over to radians. So just like we did before, I want to get rid of degrees. I want to have radians when I'm done. I let the units do the talking. I chose pi over 180 degrees. Degrees cancel. I have 60 pi over 180, which reduces to pi over 3. So 60 degrees is exactly the same as pi over 3 radians. Next, let's find the exact radian measure for 90 degrees. And as we've done before, we want the units to do the talking, so I want to divide by 180 degrees to get rid of degrees. I want to multiply by pi radians, so I'm left with radians. So we end up with 90 pi over 180 after the degrees cancel, and I end up with pi over 2 radians because 90 goes into 180 2 times. So pi over 2 radians and 90 degrees are exactly the same thing. And we can't seem to stop, so now we're going to do 120 degrees, and I'm going to, again, multiply by pi over 180 degrees. So I multiply by pi over 180 degrees, the degrees cancel, I end up with 120 pi over 180, 60 goes into both of them, and I end up with 2 pi over 3 radians is exactly the same as 120 degrees. There is no difference other than we're using different units to describe them. And now let's just knock out the next 4 here all on one screen. Let's find the exact radian measurement for negative 45 degrees, 250 degrees, 450 degrees, and 360 degrees. Again, we're going to multiply by pi radians over 180 degrees. So we multiply each of these by pi over 180 degrees. The degrees cancel. And so you basically end up with the angle times pi over 180, and then you reduce it. And you can see that we end up with negative pi over 4, 25 pi over 18, 9 pi over 5, and to no one's surprise, 2 pi. Well, now let's go the other direction. Let's convert radians over to degrees. And the only change is we're still multiplying by 1, but we're going to multiply by 180 degrees over pi because we want to get rid of radians, and we want to have degrees when we're done. So I multiply by 180 degrees over pi. We still have degrees with us. It looks like the pi's cancel out. That won't always be true converting from radians to degrees, but in this case the pi's cancel out. And 4 goes into 540 135 times, so 3 pi over 4 radians is exactly 135 degrees. And let's move on to 5 pi over 3. And again, we multiply by 180 degrees over pi. 3 goes into 180 60 times. The pi's cancel out. 5 times 60 is 300. 5 pi over 3 radians is exactly 300 degrees. And next up is 3 pi over 2. And again, we multiply by 180 degrees over pi. The pi's cancel. 2 goes into 180 90 times. 3 times 90 is 270. So 3 pi over 2 radians is exactly 270 degrees. And next up is 11 pi over 6. And to no surprise, we multiply by 180 degrees over pi. The pi's cancel. 6 goes into 180 30 times. 30 times 11 is 330. So 11 pi over 6 is exactly 330 degrees. All right. Next up, we want to express the angle in terms of degrees, minutes, and seconds. So we're going to convert from radians to DMS. Well, we can't do that directly. We first have to take it to degrees decimal, and then we'll change that to DMS, degrees, minutes, and seconds. So our first step is to multiply by 180 degrees over pi radians. Again, we want degrees when we're done. That's why 180 degrees is up top. We want to get rid of radians, although you don't see it here because you don't see the pi on that 3. It's still 3 radians. So we're basically canceling out radians when we do this. Do it all on your calculator. Remember, use the pi key. Don't use 3.14. 3 times 180 divided by pi equals. You get 171 point, a bunch of decimals. Leave it all in your calculator. We will now convert that 171 plus a bunch of decimals over to degrees, minutes, and seconds. So you remember from earlier when we did this, in my calculator, I should subtract off the 171. I multiply the decimal by 60. That gives me 53 point something. I don't care about the point something. I should subtract off the 53. I times that by 60. I get 14.4. So I end up rounding that off to 14. So there it is, 171 degrees, 53 minutes, 14 seconds. And so 3 radians is approximately equal to 171 degrees, 53 minutes, 14 seconds. Again, on that, after you multiply by 60 the first time, you get that 53 point. Don't round off there. That's just 53. You truncate it. Take whatever decimal you have, multiply that by 60, then we round. Let's do that again. Let's convert 5.6 radians over to degrees, minutes, and seconds. And again, we have to convert to degrees decimal first, and then we go to degrees, minutes, and seconds. And here's the whole thing. We multiply 5.6 times 180 degrees over pi. We end up with 320 degrees, point something. And then we should subtract off the 320. We times the point something times 60. We get 51 minutes, point something. And we subtract off the 51, and we multiply that by 60, and we get 22.9, which rounds off to 23. So we end up with our answer. All right, let's find 2 positive coterminal angles and 2 negative coterminal angles for pi over 3 radians. And just like what we did when we were dealing with degrees, we're going to add, subtract, trips around the circle. In this case, though, it's 2 pi. So we're going to add 2 pi, subtract 2 pi, and we're going to do it twice. And so you notice here that 2 pi takes the form of 6 pi over 3, and you end up with 4 answers. And there's not a whole lot to say here. If you're dealing with pi over 4 angles, you'll be adding and subtracting 8 pi over 4. If you're dealing with pi over 6 angles, you'll be adding and subtracting 12 pi over 6. We were dealing with pi over 3 angles, so we added and subtracted 6 pi over 3, and that represents a trip around the circle. Let's do the same thing for 7 pi over 6. So just as I previously mentioned, we'll be adding and subtracting 2 pi, which in this case will take the form of 12 pi over 6. And this looks familiar. We'll add and subtract 12 pi over 6, and we end up with 19 pi over 6 and 31 pi over 6 and negative 5 pi over 6 and negative 17 pi over 6. So we end up with 2 positive and 2 negative coterminal angles. There's actually an infinite number of them, but we'll stay pretty close. We won't go too far away from the original angle. And now let's find 2 positive, 2 negative coterminal angles for negative 5 pi over 4. Well, there's not a whole lot of difference here. We're simply going to add and subtract 2 pi, which will take the form of 8 pi over 4. And by adding and subtracting 8 pi over 4, we end up with 3 pi over 4, 11 pi over 4, negative 13 pi over 4, and negative 21 pi over 4. As I said earlier, there's an infinite number of coterminal angles, both positive and negative, with all angles. But we will stay rather close to the original angle. That's it for Part B of Lesson 1. You're now able to complete the online homework for Lesson 1. Get to work.